Hi, and welcome to the 15-minute maths. 15-minute math, 15 questions, 15 minutes. You can try and time yourself to see if you can do it in 15 minutes, or you can take that bit longer and try and improve over time. But this is week one, the very first of these videos. There'll be 4 a week: Monday, Wednesday, Friday, and the weekend. And as I say, time yourself or just see if you can improve these skills. And we're trying to get you ready for high school maths. Some of these skills are definitely the things you'll need to know for high school mathematics. So here we go. Here's the first one. What I'd like you to do is just take a time to pause the video, look at that, and then we're going to go through the answers afterwards. There's another few questions below there, but we're going to pause this and then I'll go through the answers for you when you think you've had a good go at these. So pause now. And the other questions below, let's have a look below. The other questions, there we go. 15 questions, 15 minutes. Right, so if you think you've had a good go at them, let's run through these answers now. 15 questions, 15 minutes. The more maths we practice, the better we will get. Absolutely everybody can get better at mathematics. A bit like fitness and health. If you work out or you go for a run, you get fitter over time. Same with maths. If you do maths a bit more, a few times a week, you will get better and better at it. Here we go, the answers. So 4 units plus 3 units, 7 units. 5 tens plus 7 tens, 12 tens. The answer 127. Next, number 2, 9 units plus 6 units. That's 15 units. That's a 10 and 5 more. I carry my tens below here just so they don't get mixed up with the carries we do for subtractions. Now we've got 8 tens plus 2 tens plus 1 more 10, altogether 11 tens, so 115. A subtraction, here we go. 7, subtract 5 in the units, 2. 4 tens, subtract 1 10, 3 tens. 6 100s, take away 200s, 400. The answer 432. Well done if you got those first 3 right. A bit trickier here. 6 units, take away 3 units is 3. 1 10, take away 5 tens. We can't do that, leaving a positive number, so we borrow. We borrow 10 tens from 100. 10 tens, 7 hundreds, we borrow 100, which is 10 tens. So we borrow an extra one here, 11. Take away 5 in the tens now is 6 tens, and 600s take away 400s is 200. So very well done if you remembered how to borrow there. If some of you need a bit of extra practice on that, watch the video again, but in the coming weeks, you'll get better and stronger at that technique of borrowing for subtraction. Let's try some multiplication. Here we go. So what have we got? We've got 9 sevens are 63. So I'm going to carry the 6 tens there, 63, 3 in the units. 4 sevens. We can just do 4 sevens, 28, and add the 6. 4 sevens, 28, add 6 is 34. But of course, what we're actually doing is 40 times 7. This is 4 tens times 7 is 28 tens plus 6 more tens is 34 tens. So we get the final answer 343. But you can just go 4 sevens are 28 plus the 6 is 34. And the columns, this is how mathematics works with these columns. The columns with those digits sort out all the tens and the hundreds for you. Bit more tricky this one because we're multiplying by 56. I'll multiply by 6 to start with. Here we go. 6 eights are 48. So the 4, little tiny 4 carries into the 10. 6 eights are 48. 6 twos are 12 plus 4 is 16. What you've actually done is 6 20s. That's in the tens, isn't it? 6 to 12 tens plus 4 tens is 16 tens. But again, the columns deal with that for you. 6 threes are 18 plus 1 is 19. That's 19 in the hundreds. Here we go. Now we're doing 50s. This isn't 5 times 8, it's 50 times 8. So we have to remember to add a 0 there, because if we're doing 50 times something, it's the same as 5 times the same number, but with a 0 added into the units column. Now we can just go and all the digits work themselves out in the columns. Here we go. So now we go 5 eighths are 40. Notice how I'm doing my carries really small, my main digits really big. 5 twos are 10 plus 4 is 14. 5 threes are 15 plus 1 is 16. So how many units do I end up with? 8. How many tens? 6 plus 0, 6. 9 plus 4 is 13 in the hundreds. 6, 7, 8 in the thousands, and we have a 10,000 as well. So well done if you got that one right. Fantastic. Again, if you needed some help with that and you're not sure how to multiply a 3-digit number by a 2-digit number, you'll improve in the coming weeks. 825 divided by 3. Let's just do it now. The 825. Many of you have seen this method before. You haven't. Just bear with me. Here's how we go. 3s into 8. There is 2 3s in 8. 2 3s are 6. There is a remainder of 2. So 2 3s are 6, but we've got 8. 3s into 8 go twice with a remainder of 2. Now we do 3s into 22. There are 7 3s in 22 with a remainder of 1. 7 3s are 21. We've got 22, so there's a remainder of 1. And then 3s into 15, 5. So very well done if you got that one right. If you're not quite there yet, don't worry. As I say, concentrate on doing this as much as you can through the weeks. There'll be 4 per week coming out. Do as many as you can, and you'll find yourself getting much, much, much more fluid with maths and more accurate. Here we go. 3,168 divided by 9. We do the same kind of thing. 9s into 3 don't go, but 9s into 31 do go. There are 3 9s in 31. 3 9s are 27. Now, some people might do long division, but to really, really, really help with your mental maths, try just to do it just like this. Try and think of the multiples and the remainders in your mind, in your brain, and do it all there and just carry it like this. 3 9s are 27, but I've got a remainder of 4. 27, 28, 29, 30, 31. There's a remainder of 4. So 3 9s are 27. There's a remainder of 4. 9s into 46. 9 5s are 45. 9 5s are 45. So there's 5 9s in 46 with a remainder of 1. 9s to 18. There's 2 of them. Very well done if you got that answer, 352. But don't worry if you're not quite there yet. Stick with it. There's the answers for the first 8. If you're not quite there yet, I'm moving down so you can pause again and have a go at these questions. But here come the answers. Here we go. 7 times 60. Why don't I need to do it as a multiplication like I did just above? Because 7 6s are 42, so 7 60s are 420. That's how we do it. 7 6s are 42, but it's actually not multiplied by 6, it's multiplied by 60. 420 divided by 10, yeah, you should know that's 42. 42. And it's like shifting the digits in the column. Some people say take away a 0. It's not really taking away a 0, but it's a technique that can help us think about it. Right, here we go. This is a bit more difficult now because we're tempted to read from left to right, and that won't help us in mathematics because there's an order of operations. And that order of operations, we do brackets first. Then we do indices or exponents, or sometimes of, like half of something. Depending on where you learn mathematics, maybe in Canada or the US or in India, in Australia, wherever you are learning maths, it'd be a bit different, but these are the same. Division next, multiplication next, addition next, subtraction last. So which is first in the list? Here we've got an addition and a division. What comes first? Division. Division comes before addition. So we'll do the division first. Also in high school maths, some students not quite used to working down the page. In mathematics, we work down the page. So when we want to do a bit of working out, I know I do the division first. I'm going to underline it. Underneath, I'm going to do that division. 8 divided by 2 is 4. I haven't done anything with that 5, and I haven't done anything with that addition sign. So I'm going down the page in my working, not across the page, but down the page. 5 plus 4, I can now write the final answer, 9. Very well done if you got that right and didn't work from left to right. If you got the answer of 6.5, not quite right. 5 plus 8 is 13 divided by 2 is 6.5. But in mathematics, we have an order of operations, and we do divisions before we do additions. Likewise here, we've got a multiplication and a subtraction. Multiplication comes before subtraction, so we multiply first and we work down the page. 3 7s. 3 multiplied by 7 is 21. 2 multiplied by 9 is 18. So the multiplications come first, but I haven't dealt with that subtraction yet, so I leave it there. Now I can write the final answer. 21 subtract 18 is 3. A very good job if you got those two answers right and you remember your BIDMAS, BEDMAS, BODMAS. If you're not quite there yet, don't worry. Continue, you'll improve. Right, here we go. Find the next two numbers in these sequences. So I think here we are adding 3 each time. 2 plus 3 is 5. 3 plus 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. So if we add 3 and add 3 again, I think we get the answers 20 and 23. Well done if you got those. Here I think we're subtracting. We're subtracting 7, subtracting 7, subtracting 7, subtracting 7, 22, subtract 7, 15. 15 subtract 7, 8. Again, very well done if you got those right. Very important part of high school mathematics also is not just doing number work like this, but being able to interpret a question. Here we go. It's a time question, often catch students out. Question number 14. Let's see how you did with this. Jane starts watching a movie at 4:20 p.m. At 4:20 p.m. Let me just write that properly. 4:20 p.m. The movie is 117 minutes long. Now, 117 minutes, you can think of this in two ways. It's either 1 hour and 57 minutes, because, of course, 2 hours is 120 minutes. Or you can think of it as 2 hours and then, or I should say, 3 minutes less than 2 hours. 3 minutes less than 2 hours. So it depends on how you think about it. 117 minutes is 1 hour 57 minutes, so nearly 2 hours, or you can think of it as 3 minutes less than 2 hours. Whichever way you go, you might want to say, okay, well, I'm going to start at 4:20. 4:20. I'm going to add 2 hours. So if you add 2 hours, you get to 6:20. But then you've got to go back 3 minutes, because 117 minutes is 3 minutes less, and you'll end up at the correct time that it finishes, which is 6:17 p.m. Okay, so very well done if you got 6:17 p.m. You could, of course, just add on 1 hour and then add on 57 minutes, and you will get the same answer. So 6:17 p.m., which I've not written particularly well, so let me just write that again. 4:20, add 2 hours would be 6:20, take away the 3 minutes would be 6. There we go, that's a bit better, isn't it? 17 p.m. I do like my students to write their answers nice and clearly, so I should be doing the same thing myself, shouldn't I? Okay, and 15, let's have a look at 15. 15, I've seen a nice few ways of doing this question. I've looked at some ways of learning mathematics in Singapore, and they are very visual in their kind of way of explaining things in Singapore. So let's have a little look if I can do a visualization of this. It says Jordan has $8 more than his friend James. Altogether, they have $30. So I've seen this before in Singapore, where you just draw a bar like this, and that's the bar of money for Jordan. He's got more money than his friend James. He's got more money. It doesn't really, we're not making these accurate bars, but what we then look at is we annotate this, and it's a visual way of looking at it. So if this is Jordan's money, and this is James's money, and we know that this is worth 8, he's got $8 more, but in total, together they've got $30. You can look at that and try and problem solve, and you think, well, okay, there's a way of doing this. We can look at that. Both of these bars together, this and this, have to be equal to 30, but that little bit there is 8. How can we go about doing it? So some people might look at it and go, well, if we take that 8 away, so together all of this has to be 30. So if we take the 8 away, 30 take away the 8 is 22. So taking away that 8 is 22. That means that these two sections here, this section and this section, has to add up to 22. And of course, they're the same size. This section plus this section have to add up 22, and they're the same size. So then you can do 22 divided by 2 is 11. So one of these sections is 11. So James has got $11, and then Jordan has $8 more, 19. Quick check, does that add up to 30? Yes, and there is your answer. So that's a way I've seen in Singaporean mathematics. I quite like it. It's a visualization of what it is. You just draw one bar for one amount of money, a bar either bigger or smaller depending on the question and the language in the question. Here, Jordan has the bigger bar. Okay, you're told a little bit of difference is 8, and that helps you visualize how to solve this problem. So if you got that, very, very well done. There are algebraic techniques of doing this, but in Singaporean maths, they leave algebra until a bit later than you might imagine, and I quite like doing that too. Let's just think about this in a problem-solving way and move on. Okay, so the message is clear here. The more maths you do, the better at it you get. If you keep working that muscle, your brain, in terms of mathematics, your brain will become stronger. You'll be better at maths. Everybody, no matter who you are, how old you are, or where you are, can get better at maths. So 15-minute maths, 15 questions. Well done for sticking at it. I'll see you in a couple of days. Thank you.